You know, humanity has managed to unlock the most fundamental forces of the universe, and in doing so, we created a weapon of almost unimaginable power. So today, we're going to break down the incredible science behind the nuclear bomb.
Just look at this. The explosion over Nagasaki was like setting off 21,000 tons of TNT. But get this, that was just the beginning. The hydrogen bombs we have today, they can be thousands of times more powerful. So how in the world did we figure out how to release the insane amount of energy that's hidden inside a tiny atom?
Well, the story really kicks off during World War II with the top-secret Manhattan Project. But the creation of these weapons, it didn't just end a war. Oh no, it completely rewrote the rules of warfare, military strategy, and really, global politics forever. But to really understand the bomb, we have to go deeper than just the history. We have to look at the revolutionary physics that made it all possible. And it can all be summed up in one single, iconic equation. Yep, you know this one, Albert Einstein's famous formula, E equals mc squared. This simple-looking equation is the scientific key to the whole thing. And the secret sauce is that c squared, the speed of light multiplied by itself. It's this absolutely massive cosmic multiplier which reveals how even a tiny speck of mass can be converted into a staggering amount of energy.
So what does that actually mean? Well, it means that mass isn't just stuff. It's incredibly concentrated energy, just waiting to be released. In a nuclear reaction, a tiny fraction of an atom's mass literally vanishes, and in its place, a catastrophic amount of energy is born. That single principle is the entire source of the explosion.
And it turns out there are two main ways to unleash that energy. Two different blueprints, if you will, for an atomic explosion: fission and fusion. Now, these two processes are basically polar opposites. Fission, which was used in the very first atomic bombs, is all about splitting heavy atoms like uranium apart. But fusion, that's the powerhouse behind the much scarier hydrogen bomb, is about smashing light atoms like hydrogen together, which releases even more energy.
And here's where it gets really clever. The relationship between them is fascinating. You actually use a smaller initial fission reaction as the trigger. It creates the mind-boggling heat and pressure you need to kickstart a much larger, way more devastating fusion reaction. So one bomb basically acts as the detonator for an even bigger one.
Okay, so for now, let's zero in on that original design, the fission bomb, and take a look at the key parts that all have to work together perfectly to create that devastating chain reaction.
You might think a nuclear bomb is just sitting there, ready to go off at any second. But before it's detonated, it's actually remarkably stable. The core material is kept in what's called a subcritical state. It's this carefully engineered system designed to do, well, absolutely nothing until the exact right microsecond. So let's break down the parts, shall we? At the very heart of it, you've got the fissile core. That's the nuclear fuel, usually plutonium, with atoms just itching to be split apart. Wrapped around that, you have conventional explosives. Believe it or not, that's the non-nuclear trigger. A neutron initiator acts as the match to light the fire, while a superdense tamper shell holds the core together for just an extra split second, bouncing neutrons back in to make the whole explosion way more efficient.
So you have all these stable parts. How do they go from just sitting there to creating a city-leveling explosion? Well, it all happens in an incredibly fast, violent, and perfectly synchronized sequence of events. And when I say fast, I mean it's almost impossible to comprehend. The entire nuclear chain reaction is over and done within about a millionth of a second. The physics is complete before that iconic mushroom cloud has even started to form. It's just staggering.
It all happens in this precise, violent cascade. First, a conventional explosion crushes the core. This forces it into a state of supercritical mass, and that is the absolute point of no return. It's where the atoms are packed so tightly together that a runaway chain reaction is guaranteed. From there, it's just pure physics leading to a massive release of energy.
The whole process begins with a non-nuclear trigger. Conventional explosives that surround the core are detonated with incredible precision. But they're not designed to create a blast that goes outward. Oh no. They're designed to focus a perfectly symmetrical shockwave inward. That inward shockwave slams into the plutonium core, squeezing it instantly. This compression, this is the crucial moment. It forces the atoms so close together that a runaway chain reaction becomes inevitable. The stable, inert material has just become explosive.
And as that chain reaction just tears through the core, with neutrons splitting atoms and releasing even more neutrons, the temperature skyrockets. We're talking millions of degrees, creating conditions just like the very center of our sun.
All of this immense energy creates a brilliant fireball that just vaporizes everything at ground zero. It generates a devastating shockwave that travels faster than the speed of sound. And as that superheated bubble of gas rises up, it sucks up dust and debris from the ground, creating that infamous, terrifying mushroom cloud.
Okay, so the science is one thing. It's just mind-blowing. But the existence of this technology, it has completely reshaped our world, and it raises these profound questions about war, peace, and our own survival.
This one invention created a whole new era of mutually assured destruction. This terrifying logic that basically made all-out war between superpowers unthinkable. It kicked off decades of tense arms control treaties and, of course, endless ethical debates about a weapon that causes such indiscriminate harm and leaves behind an invisible poison of radioactive fallout for generations.
So this leaves us with the ultimate paradox, doesn't it? By creating a weapon so powerful that it could literally end civilization, have we actually prevented more wars than we've caused? Has this knowledge made the world safer, or have we just been living on borrowed time? It's a question that's definitely worth thinking about.